morning children. In today's class we are going to learn about monotonicity. What does this word represent? Suppose you have a curve like this. Say this is the point 3, 4 and this is the point 8, 12. So I have 8, 12. What do I see? 3 to 8, x value increases. What do I see here? 4 to 12, y value also increases. When x increases, y also increases. Or I will say, call this as x1, x2. Call this as f of x1 and f of x2. When x1 is less than x2, f of x1 is also less than f of x2. This I will call increasing function. Wherever I take the points, as x increases, y also increases. So this is an increasing function. Consider a curve like this. x1 value 2, f of x1 is 12. When x2 value is 10, f of x2 is 3. So what I see? x1 below x2 but f of x1 greater than f of x2. So these patterns we call decreasing curve. Suppose I have a curve like this. What will you say? Now also x is small but y is big. When x is big, y is small. So we have this is also decreasing curve. As I see the curve, I must know to say whether it is decreasing or increasing. Any quadrant it may come. Just for clarity, we are doing it in the first quadrant. A curve like this. See the value. X is small, y is also small. When x is big, y value is also big. So this is an increasing curve. So as we see 4 types, we should know these two I call. When x1 is below x2, f of x1 is below f of x2, and such curves we call increasing curves. Whereas these two, x1 is less than x2 but f of x1 is greater than f of x2. This type of curves we call decreasing. So when I see the curve, I can analyze like this. Is there any other idea to check? Suppose you are given f of x is equal to x cube. Can I see what type of curve it is before even drawing? Yes, there is a provision. Find out the derivative. X cube will become 3x square. X square is always positive. So derivative is always greater than or equal to 0. This tells me it is an increasing curve. If derivative is less than 0 or less than or equal to 0, we call decreasing curve. So when we draw, we can analyze. Even otherwise, if we find the derivative also, we can find out the answer. Derivative positive tells me increasing function. Derivative negative tells me decreasing function. Suppose I have only less than 0. I will call strictly decreasing. So these are certain words to remember. It's a strict inequality. I say the word strictly decreasing. If f dash greater than 0, we use the word strictly increasing. So we just write st dot increasing. We read it as strictly increasing. So this exercise, we may have problems of this pattern. Checking x1 less than x2, f of x1 less than f of x2, or the other way. Another pattern, we can also use derivative and check whether it is increasing or decreasing. Suppose we have a curve like this. This is increasing. After reaching some point over here, it starts decreasing. But see, when it is increasing to decreasing, increasing tells me f dash greater than 0. Decreasing tells me f dash less than 0. Can greater than 0 suddenly become less than 0? No. At a particular point, it will be equal to 0. So from greater than 0 to less than 0, if we need to go at a particular value, the value of the derivative vanishes. Similarly, the curve keeps on decreasing. At a particular point, again it becomes 0 and it starts increasing where f dash is greater than 0. So from less than 0 to greater than 0, it cannot suddenly jump. Naturally, it has to vanish. Look at the difference. In the curve, as I see the trend of it, this point I call maximum, whereas this point I call minimum because it is down. Similarly, as it keeps on, again I may get maximum, minimum like that. Now you are given an interval like this. In the interval, check where f dash is becoming 0. Before the point, it may be either increasing or decreasing. After the point also, it may be either increasing or decreasing. So finding the interval from where to where increasing, from where to where decreasing is called finding intervals of monotonicities. Mono tells me single. Tone tells me whether it is an increasing trend or decreasing trend. So monotonicity tells us about the increasing trend or the decreasing trend of the curve. As I know, from increasing to decreasing, the derivative definitely becomes 0 at a particular point. That I call local maximum. From decreasing to increasing, again it vanishes. That particular point I call local minimum. So this exercise, question number 2, we are going to do problems based on intervals of monotonicities and local extremum. What is the procedure? Number 1, find the derivative. Put the derivative equal to 0. You will get some 2, 3 values A, B like that. Draw the number line minus infinity to infinity. Mark the points here. So the entire number line becomes 3 intervals. Minus infinity to A to B and B to infinity like this. You have 3 intervals here. So we have 3 intervals. Substitute any point in this interval in the derivative. Derivative positive tells me it is increasing. Derivative negative tells me it is decreasing. So we are going to write in the particular interval it is increasing or decreasing. Then if it is increasing to decreasing, I will call the point as maximum, and decreasing to increasing, I will call the point as minimum, depending on the question and depending on the trend, the monotonicity. Decide which point is maximum and which point is minimum. Subsection 1, f of x is equal to 2x cube plus 3x square minus 12x. The question is to find the intervals of monotonicities and local extremum. Find out the derivative. 2 into x cube will become 3x square becomes 2x, x becomes 1. In all the terms 6 is common, so we can take 6 as common. 6 into x square plus x minus 2. We need to put f dash of x equal to 0. 6 into x square plus x minus 2, 0 gives me, I can factorize. I need plus 1, it is 2 1s are. Plus 2 minus 1. So 6 is to the right side 0. So 6 I can ignore. I get x plus 2 into x minus 1 0 or x is equal to minus 2 and 1. Draw the number line minus infinity in the extreme end plus infinity to the right end. Mark minus 2 and 1. How many intervals do I get? The 3 intervals we get from here, minus infinity to minus 2, minus 2 to 1, and the third one, 1 to infinity. As we mark minus 2 and 1 in the number line splits into 3 intervals. Minus infinity to minus 2, minus 2 to 1, 1 to infinity. Now, we need to substitute any random value in the intervals. Let me select before minus 2, I can put minus 3. Check minus 3 in f dash of x. 6 into minus 3 plus 2 minus 3 minus 1. This is negative. This is also negative. Negative into negative. My answer is positive. I will say strictly increasing. In the same way, check in the next interval. The next interval is minus 2 to 1. Negative to positive, definitely 0 is in the middle. So 0, I can substitute in f dash. 6 into 0 plus 2 into 0 minus 1. I get 0 plus 2 positive, 0 minus 1 negative. Ultimately, my answer is negative. So, I will say strictly decreasing. The next interval, 1 to infinity. After 1, choose many numbers are there. Easy number, I can put 2. After 1, any of the numbers, the easiest one, let me say 2. Put 2 in the derivative. 6 into 2 plus 2 into 2 minus 1. 2 plus 2 positive, 2 minus 1 also positive. Together my answer is positive. Plus into plus is positive. So I will say this is strictly increasing. So the given function is strictly increasing in minus infinity minus 2 and 1 to infinity. And it is strictly decreasing in the interval minus 2 to 1. As we take and write the increasing and decreasing, the first part of the question is over. The second part, we need to say where it is having the local extremum. Increasing to decreasing. Which point is common? Minus 2. So these two together will tell me increasing to decreasing. So that is the maximum point. Local maximum at x is equal to minus 2. Here it is decreasing to increasing. When it is decreasing to increasing, It tells me it is local minimum. So local minimum at x is equal to 1. So minus 2 to 1 decreasing, 1 to infinity increasing tells me 1 is the minimum point, and this tells me this is minus 2 is the maximum point. Substitute the value in f of x. So local maximum at x is equal to minus 2. Local minimum at x is equal to 1. Substitute the values in f of x and find the answer. F of x equals to, when x is minus 2, 2 into minus 2 cube, 3 into minus 2 squared, minus 12 into minus 2. 2 into minus 8 plus 3 into 4 minus into minus plus 12 2s are 24. Simplify the answer. Minus 16 plus 12 plus 24. It is 20. So local maximum is 20. Local minimum at x is equal to 1. Find out f of x. 2 into 1 cube plus 3 into 1 square minus 12 into 1. 2 plus 3 minus 12. It is minus 7. So local minimum, the value is minus 7, and that is the answer. Question number 2. Find the intervals of monotonicities and hence find local extremum. X by x minus 5. You can treat it as u by v procedure. U equals x, v equals x minus 5. U dash x will become 1. V dash again x will become 1. 5 can become 0. U by v, the whole dash is v u dash minus u v dash by v square. Applying this formula in the question, f dash of x is equal to v u dash cross multiply x minus 5 into 1 minus u v dash x into 1 divided by v square, x minus 5 the whole square. F dash of x is x and x will get cancelled. We are just left with minus 5 by x minus 5 the whole square. X minus 5 the whole square is always positive, but minus 5 is always negative. So this entire answer I will say less than 0. F dash of x, unlike the previous problem, I cannot make it equal to 0. So this entire answer, denominator is a perfect square, so it is always positive. Numerator is a negative number, so negative by positive is always below 0. We have to eliminate x equal to 5 alone. So when x is not equal to 5, remember in all the mathematics problems, denominator should not become 0. So when x is not equal to 5, denominator is not becoming 0 and the entire answer is less than 0. To write it in interval model, let us say f dash of x does not exist. Where it does not exist? When the denominator equal to 0. X minus 5, 0 tells me x is equal to 5. I draw the number line minus infinity, 5, infinity. In the interval minus infinity to 5 or in the interval 5 to infinity. Put some x value before 5, let me say 4. After 5, let me say 6. Check the derivative symbol. F dash equals to minus 5 by 4 minus 5 the whole square, that is negative, decreasing. We will say strictly decreasing. Similarly, when I put 6 also, minus 5 by 6 minus 5 the whole square. This is positive, but this is negative, altogether negative. So here also it is decreasing. So we will say f of x is strictly decreasing in minus infinity to 5 union 5 to infinity. Only which point is not inclusive? 5. Implies no local extremum. And that is the answer. Third subsection, e power x by 1 minus e power x. The same pattern. Call the numerator as u, the denominator as v. U dash, e power x derivative, e power x, v dash. 1 becomes 0, e power x derivative, e power x. The formula u by v the whole dash is v u dash minus u v dash by v square. Applying the formula in the problem, f of x we write f dash of x equals to v u dash 1 minus e power x into e power x minus u v dash e power x into minus e power x divided by v square 1 minus e power x the whole square. It is 1 into e power x minus e power x into e power x minus into minus plus e power x into e power x. Denominator 1 minus e power x the whole square. These two terms we can cancel. So f dash of x is equal to e power x by 1 minus e power x the whole square. What will you say about e power x? It is a positive quantity. Even if x is negative, e power x is positive. 1 minus e power x the whole square is also positive. Therefore, this is greater than 0. Like the previous problem, I can say it is strictly increasing function and hence there is no local extrema. You can just finish the problem in that way. Which one should I eliminate? 1 minus e power x 0 tells me x value 0. Eliminate x value 0 alone. Or if we want to do it in steps, how shall I proceed? F dash of x not equal to 0. F dash of x does not exist when the denominator equal to 0. The denominator is 1 minus e power x 0. E power x is 1 tells me x is equal to 0. So the first interval I can put minus infinity to 0. The second interval 0 to infinity. Minus infinity, 0, infinity. We have the two intervals. X value before 0, I can put some value, say minus 1. After 0, plus 1. What about f dash of x? F dash of x will become e power minus 1 by 1 minus e power minus 1 the whole square. Even if e power minus 1 is coming, I can rewrite it as 1 by e which is positive. So just write greater than 0 tells me strictly increasing. The same idea for the second one also. Put x is equal to 1. E power 1 by 1 minus e power 1 the whole square. Now also positive. So say strictly increasing. So in both the intervals it is strictly increasing and therefore there is no local extremum. F of x is strictly increasing in minus infinity 0 and 0 to infinity implies no local extrema. Subsection 4, f of x equals x cube by 3 minus log x. F dash of x. X cube becomes 3x square by 3 minus log x becomes 1 by x. 3 and 3 cancels, taking LCM. X Cross multiply, it is x cube minus 1. Put f dash of x equal to 0. We get x cube minus 1 0 or x is equal to 1. F dash of x does not exist when the denominator is 0. What is the denominator here? X. So x is equal to 0. Mark all this in the number line. Say minus infinity to infinity, 0, 1. Can I mark minus infinity in this problem? No, because it is given x is greater than 0. So remove this part. We should mark only from 0. So what are the intervals we get? 0 to 1, 1 to infinity. Substitute some x value 0 to 1. I can put 1 by 2. Substitute in the derivative. 1 by 2 cube is 1 by 8 minus 1 by 1 by 2. It is negative. 1 by 8 minus 1 is definitely negative, and so we will say strictly decreasing. What about the next interval? 1 to infinity. After 1, say a value 2. Put x is equal to 2 in this value. 2 cube minus 1 by 2, and it is definitely positive. This tells me strictly increasing. So we shall take and write. F of x is strictly increasing in 1 to infinity and strictly decreasing in 0 to 1. How to find out the local maximum and minimum? Check this. Decreasing to increasing tells me it is minimum. So we get local minimum at the common point. 0 to 1, 1 to infinity. The common point is 1. So we will say local minimum at x is equal to 1. There is no other interval to check for maximum. So we will say local maximum nil. We do not have local maximum. Only local minimum is there. Put x is equal to 1 in the function. We get f of x is equal to 1 cube by 3 minus log 1. 1 cube by 3, 1 by 3, log 1, 0. And so we get 1 by 3. So the local minimum value is 1 by 3 at x is equal to 1. And there is no local maximum. So we will just write no local maximum for this problem. So there are problems where only minimum may come but maximum no. Only maximum may come and no minimum, or both. Sometimes we don't have both also. Subsection 5, f of x equals sin x cos x plus 5. Whenever I see sin x cos x, immediately rewrite it as sin 2x by 2 plus 5. We know sin 2x is 2 sin x cos x. So, sin x cos x comes in calculus. Remember to rewrite it as sin 2x by 2, which is easy for us to integrate or differentiate according to the question. Here, let us find out f dash of x. Sin 2x, the formula cos 2x. 2x will become 2 divided by 2. 2 and 2 gets cancelled. 5 constant will become 0. So what is my answer? Cos 2x. Putting f dash of x equal to 0, we get cos 2x is equal to 0 or 2x is equal to. When cos is 0, cos 90 is 0, or we will say odd pi by 2, cos x is becoming 0. Odd pi by 2. How will I rewrite it? It is 2n plus 1 pi by 2. But in this question, the interval is only 0 to pi by 2. So 1 pi by 2 is my answer. What is x? Pi by 4. The interval becomes 0 to pi by 2. In trigonometrical functions, they have to give interval. In circular functions, we will have infinite number of intervals. So 0 to pi by 2 is the value given. In 0 to pi by 2, mark the value pi by 4. So we have two intervals, 0 to pi by 4, pi by 4 to pi by 2. Put some value, say pi by 4 is 45, put pi by 6 here. Pi by 4 to pi by 2, let us put pi by 3. In f dash, the answer is cos 2x, it is cos 2 pi by 6, cos 2 pi by 3. Pi by 6 is 30, 2 pi by 6 is 60, first quadrant cos is positive. 2 pi by 3 tells me it is in second quadrant, cos is negative. So 0 to pi by 4 it is strictly increasing, and pi by 4 to pi by 2 it is strictly decreasing. Increasing to decreasing tells me it is local maximum. Increasing to decreasing tells me it is local maximum. The common point is pi by 4. So local maximum at pi by 4. F of x strictly increasing in, you can put 0 closed interval as given in the question, pi by 2 closed interval as given in the question. But pi by 4 you shouldn't put closed interval, because at pi by 4 derivative becomes 0. So remember to put open interval at pi by 4. F dash changes sign from plus to minus when x is equal to pi by 4. That implies it is local maximum. F of x is equal to sine 2 into pi by 4 by 2 plus 5. Sine 90 will become 1 by 2 plus 5. Taking LCM, it is 1 plus 10 by 2, or it is 11 by 2. So local maximum equal to 11 by 2 at x is equal to pi by 4, and in this question also there is no local minimum, and that is the answer.